Welcome back, math friends. We're still working on section 7.2 notes for precalculus. We're looking at examples 3 and 4 right now, and these are a little bit different. So it's like somebody has taken a formula and started plugging degrees into it. And so our job is to kind of work backwards this time. So what we want to do for each of these examples is we want to try to match what's been given to us with one of the formulas on our identity sheet. Okay, so when I look at example number 3, I see a cos minus a sine. So when you look at your identity sheet and you look at your two possibilities for cosine, the one that looks like a cos minus a sine is the cosine of x plus y formula. Okay, so this has the form, this has the form of cosine of x plus y, okay? And if that's the case, then this example is somebody trying to figure out cosine of, this would be x, y, right? So cosine of 18 degrees plus 12 degrees, which is equal to cosine of 30 degrees. And we know the cosine of 30 degrees, that's our first ordered pair on the unit circle. Cosine is our x value. So the cosine of 30 degrees is the square root of 3 over 2. In my second example, I've got sine cosine minus cosine sine. So that looks like one of our sine formulas. And if you check the signs, hopefully you notice that this one has the form of the subtraction formula. So this is a sine of x minus y, or subtraction formula. So 3 pi over 4 is going to be our x, and pi over 12 is going to be our y. So this is sine of 3 pi over 4 minus pi over 12. Okay, now obviously if I want to combine those together inside the parentheses, I'm going to need a common denominator. 12 would work, so I'm going to rewrite 3 pi over 4 as 9 pi over 12. So 9 pi over 12 minus 1 pi over 12 gives me 8 pi over 12, which of course can be reduced to 2 pi over 3. All right, so now think about your unit circle. 2 pi over 3 is in the second quadrant. We can use the terminal point of pi over 3. So the sine value at the terminal point pi over 3 is going to be the square root of 3 over 2. And in the second quadrant, sine is positive. So our answer is going to be square root of 3 over 2. All right, now we're going to get back to a little bit of proof here. I promised you that section 7.1 and 7.2 would have plenty of proofs, so here we are back again with proofs. And we are asked to prove, that cosecant of pi over 2 minus u is equivalent to secant u. All right, so the first thing that I'm going to do is I am going to rewrite the left-hand side in terms of sine, because cosecant is the reciprocal of sine. So my first step is going to be to write this as 1 over the sine of pi over 2 minus u. And then, since this section is all about using addition and subtraction formulas, I am going to use the subtraction formula for sine from my identity sheet. Pi over 2 is my x, u is my y, okay? So it's going to be sine x cos y minus cos x sine y. So I'm going to plug that in accordingly. So I'm going to have 1 over sine of pi over 2 cosine of u minus cosine of pi over 2 sine of u, okay? And now I can do a little bit of simplifying, because sine of pi over 2 and cosine of pi over 2 in that expression are known values, okay? So let's see here. I've got 1 over sine of pi over 2. Pi over 2 is at the top of our circle. The sine value is our y value, right? So that's going to be, that ordered pair is 0, 1. So sine is 1. So this is going to be 1 times the cosine of u minus cosine of pi over 2 is 0. So 0 times sine u, that's just going to make that part of the expression cross out. So I'm left with 1 over 1 times cosine u is just cosine u. And what was I supposed to prove? I was supposed to prove that this was equal to secant. Well, I hope we can all agree that 1 over cosine is equivalent to secant because secant is the reciprocal of cosine. So I'm done. Secant u equals secant u. Okay. The second example here, number 6, is a little bit easier. It's going to go a little bit faster. Okay, so I have to prove again that the left side is equal to the right side. Looks like I've got the subtraction of two angles inside my cosine function. So I am going to be looking at my cosine subtraction formula from my identity sheet, which is going to be cos x cos y plus sine x sine y. So I'm going to go ahead and plug that in. And again, x is my x value and pi over 2 is my y value. So this is going to be cos x cos pi over 2 plus sine x sine pi over 2. Okay. And again, we just did this. Cosine of pi over 2 is 0. So I end up with cosine x times 0 plus sine x, and sine of pi over 2 is 1. Well, cosine x times 0 just crosses out, so I'm left with sine x times 1, which is sine x. So sine x equals sine x. I've just proved that the left side equals the right side. All right, last example in this section. On the left side here, I've got sine of x plus y minus sine of x minus y, and that is equivalent to 2 times cos x sine y. So basically, we are just going to be manipulating our formulas. We're going to start with sine of x plus y, okay? So sine of x plus y can be written out as, again, just using my identity sheet, sine x cos y plus cos x sine y. Okay, that's my sine of x plus y. Just going to change color here. Then I've got a minus sign. So everything that I subtract, or everything I put in the parentheses is going to be, that negative is going to get distributed to it. That's this negative right here. Now I'm going to use my sine subtraction formula, which is going to be sine x cos y minus cos x sine y. Sorry, I went over the line there. Okay, so then again, my next step is going to be to distribute that negative. And then I can simplify things a little bit, and you'll see it's going to come together nicely. So the orange part I'm just going to rewrite here. Sine x times cos y plus cos x times sine y minus sine x cos y, and then minus a negative becomes plus cos x sine y. Whoops, and I don't need that parenthesis there. All right, and now as you can see, I've got some like terms that are going to cancel out. Right here, I have a sine x cos y, and right here I have a negative sine x cos y. So those are going to cancel out. And then I have cos x times sine y and cos x times sine y. I have two of them. So when I combine those together, that equals 2 cos x sine y, which is what I was supposed to get my left side, cos x sine y, which is what I was supposed to get my left side to equal. Verified. And that's the end.